This week's lecture is based on digital data. We are going to look at the different ways that we could use digital data using GIS. So in regards to digital data is developed by governments, and again, governments provide public services such as health, transportation, water, and energy. It's important to monitor these different sectors spatially. So again, many spatial data currently exist in digital forms. When we're looking at digital data, we're looking at data such as roads, political boundaries, water bodies, land covers, soils. So we're going to look into that later in the lecture. So for it to be digital means that they are directly transferable to other digital devices and GIS systems. So this is accessible, users can access this and download digital data. And we all know how easy it is to download digital data, especially for our lab class when we're using Living Atlas. That is all digital data that any user could use and manipulate and analyze the data in their own way and their own interests on what they're specifically researching for. Spatial data sets are required for disaster planning and management and national defense, as well as infrastructure development and maintenance. So business, nonprofit, education, and science, as well as governmental bodies may draw benefit from the digital spatial data, as these organizations benefited in prior times from government-produced paper maps. So here we have an example of digital data. In this first column here, if I could draw, in this first column, this is showing us vector formats. So we have point vector format here with the points representing population. This is a polygon vector format. So it's showing us the boundary. And this is a line vector format. So again, vector format only shows in points, lines, or polygons. This example here of elevation, this is a DEM, digital elevation model. And we could see here that this is a DEM of this specific portion of the boundary. This is showing us elevation, and what we learned previously is that elevation data is a raster format. So elevation is one example of a raster data format. And then again, this map is produced here. So digital data comes in both raster or vector formats. So national and global digital data. So national data sets are more common, such as United States federal government data sets or Mexico's federal government data sets. For our lab assignment, we'll be looking at the United States data set as well as Mexico's data set. National governments commonly develop, organize, archive, and distribute the national data sets, and they must oversee the planning, construction, and the management of public infrastructure. Now, when it comes to global digital data sets, these are less common, and this is due to differences in spatial data collection. As we know, each country, they gather spatial data differently. It could be due to projections, so map projections or datums. We learned in our previous lecture that it's good to use a local datum. If, for example, for Australia, you would want to use the local datum to find that lost hiker. So again, different countries use different map projections, different datums for an accurate representation of the spatial location. Also, they use different measurement units or different data variables. So it differs from different countries. But there is a standardized way to gather global digital data, and this is developed from the global satellite data such as MODIS or vegetation. So again, global data sets have often been developed using global satellite. We're looking at satellite imagery. So this is an example of a raster data format. And data sets are limited, and NASA provides a large and diverse group of global spatial data sets, which include elevation, land use, ecosystem type, and vegetation productivity. And this is due to their leadership in the development and application of satellite images at a range of spatial scales. So if you go to the NASA website, you'll be able to download these satellite imageries. Other global data sets are Natural Earth. Natural Earth is a volunteer collaboration. And there is Global Land Cover Facility as well as OpenStreetMap. In the beginning of the semester, we looked at how OpenStreetMap was used for the disaster that occurred in Haiti with that major earthquake, and how there was volunteers, coordinating and plotting spatial locations so they could get help. So again, OpenStreetMap is an international volunteer collaboration. Now for the digital data for the United States, these are examples of digital data. So we have the United States Geological Survey, also known as USGS, and this is a great single source of geospatial data for the United States. Here I have a link, but I highly encourage you all to check out all the different links that are in our module for this week, all the different data you could use for your GIS project. So again, keep in mind we are doing a project for this class. And an example of the data sets that USGS provide is the National Elevation Data Set. So this is similar to this picture as well as this DEM or digital elevation model. Another type of digital data for the United States is the National Map Survey, and they produce digital data for most of the United States, and their data consists of the political and civil boundaries, the transportation, and the hydrography. And the National Map Survey both provide it in vector or raster format. So here is an example of the digital elevation model that's available at various resolutions and coverage areas for most of the world. Again, this DEM is in a raster format. So there are many tiny pixels here in this image. That's why it is a raster format, because of the pixelated imagery. This is a figure near Mono Lake in Eastern California, and this was produced using data available from the USGS. And you could see a string of lava flow on the apparent right side of the image. A next type of digital data set that's important is hydrologic data. And an example of that is the National Hydrologic Dataset. And this contains digital spatial data about surface waters such as rivers, streams, and canals, as well as coastlines, dams, and stream gauges. So this is a combination of the digital line graph data and EPA river reach data. So we are looking at the water drainage network of the United States, and this National Hydrologic Data Set was retired in 2023, but even though it was retired, it is still available. So if you're interested in looking at water bodies from 2023 and before, I highly encourage you to look into the National Hydrologic Data Set. Now they're using a newer data set called the 3D Hydrography Program. So there are other hydrologic data sets that you could use besides NHD. There is USGS, Natural Earth, and Kashi. So for our lab assignment, we will be using the Natural Earth data set. And again, we could see these are vector formats here in this image. We could see line features. We could see polygon features. Here it says these polygon features, the light gray are wetlands, and then the dark polygons are dark polygon features, just like right here. This is showing us our water bodies. And then we have our streams represented as line features. So this is how the data would look if you downloaded the data from NHD and then downloaded it into ArcGIS Online or ArcGIS Desktop. Also, it'll be good to look at if this is available already in the Living Atlas. Our next type of digital data are digital images, and this is available from a variety of sources. USGS collects digital images every 5 to 10 years, and again, this is an example of a raster format because it is pixelated. The high-resolution orthophotographs, also known as HROs, are the best quality for the highest resolution. And this is useful to use these digital images for planning, infrastructure mapping, and disaster management. So this is an example of a high-resolution orthophotograph distributed by the USGS. And it just tells you how you could see individual persons on near the flagpole in the upper left part of the island. So this is good quality. So high resolution means that it's very well pixelated and good quality. And the image archives go back to the 1950s for most of the United States. And again, we could also use this for vegetation mapping. So you could classify the different types of vegetations, such as deciduous trees or evergreen trees. And that's when you are classifying vegetation. This is when you get into national land cover data. So again, this is based on satellite data. This is a raster format type of data. And one of the most popular data sets is the National Land Cover Database, also known as the MRLC. You could see here for figure 7-17 from our book, this is a time series of national land cover data for an area north of Las Vegas, Nevada. And the NLCD categorizes land cover into 21 classes. One of those classes could be urban. And here we could see that the urban class is identified as red, whereas the agricultural areas, which are light gray, that's another class. So we could see the development of Las Vegas, especially in this area right here from 2001. We could see it gets it gets more developed, especially by 2011. So land cover data is useful to see how the land has changed across time. So this is good for time series and also to see a place that gets deforested. So so this is the national land cover data. Lastly, the most important I want to go over, and this is important because our lab assignment's based on the digital census data. So the United States Census Bureau developed a database system to support the national census, and this is called the Census Tiger system. This was used to organize areas by state, county, census tract, and other geographic units for data collection. So we could see here on this map, this is using only census tracts. So this is a geographic unit. So we are being more specific about the population in these census tracts. Again, this is maintained by the United Census Bureau, and this links census statistical data to geographic entities. Like we see here, our statistical data is population change, and we're linking it to geographic census tracts. Other data that you could map are population size, age, income, and health. And it's important to know that many U.S. government data sets are provided with codes compatible to the U.S. Census Bureau data. So, for example, if you're interested in information about elementary schools and you want to link it with U.S. Census Bureau data, it is easy to link the education attributes to, let's say, age. So you would have to join the two tables. So you would download a table from the Department of Education as well as a table with age, and you would join it together. So it's easy to join these different data sets. And you could also look into the Department of Transportation and link it with health from the United States Census Bureau, or you could look at the Centers for Disease Control and link it with health. So that's one great way to use digital census data, is to add other information, other data sets that you're interested in. Again, with digital census data, this is in vector formats. So we are looking at polygon features, line features, and point features. Here we are seeing polygon features. And these polygons are our census tracts. But again, with line features, you could use roads or railroads or air flights. And for point features, you could put where the schools are located. So here's probably one school location. This is a hospital in this part of the census tract. And then for polygon features, this is a great representation of polygon features. So here is another map of the US Census data, and it's showing you the traffic deaths per 100,000. So again, you could use the digital census data to map anything that you're interested in. For summary, digital data are from a variety of sources, like we just saw: digital images, national land cover data, or digital census data. And from reading your chapter, you could see you could look at wetlands or soil for a specific region. So it's also to keep in mind that it's important to evaluate the data that you're using in GIS, such as who is producing the data, what are the source materials, the data set information, and how they are delivered. So we have been using ArcGIS Online to look at the data in Living Atlas or ArcGIS Online. And when we click on each data, it does provide us information on who created it and what are the source materials. So that's it for a lecture. Thank you for watching.